All right, welcome back to another day in virtual trigonometry. We are having a great time here moving forward and not just staying stagnant. And so yesterday, you might remember we started this conversation about why use radians anyway. And we didn't have a long conversation about it, but one of the things that we found was that there was a huge benefit, just one of the benefits, in finding arc length. We had seen that before in geometry. One of the things that we would do is we would have to do all of this to find the length of an arc. But yet in trig, using radians, the length of an arc, s, is just equal to radius times theta, as long as theta is in radians. That's the little catch, the little clause that we gotta have. And so this is pretty simple. All right. And so we're very thankful for that. There's other benefits, but that's the one we're dealing with right now. And so then yesterday, if you watch yesterday's video, we walked through how to find arc lengths, whether the theta was given to us in radians or whether the theta was given to us in degrees. And then we walked through an example about, well, what if you were on a Ferris wheel? And we're talking about, well, if you had the diameter of the Ferris wheel and you traveled 120 degrees, because think about it, everybody in the real world is not really going to have a connection with radians. They're going to, if anything, they're going to be thinking about degrees. And so we were able to convert that. And we were able to figure out how long of a trip or a travel they had. And for a little bit more information on those, you can watch yesterday's video. But the thing that we missed out on was we missed out on this other example that looks something like this. Now, this might be a crazy looking picture, and I apologize. I know it is far from perfect. But what I want you to do is I want you to imagine that Rashawn, being an incredibly intelligent guy, is laying on his back in this field, and he looks up and he sees a 747 jumbo jet flying by. Now, Rashawn, having these amazing eyes, is able to measure the angle that 747 fills. The proper word is subtends. This angle right here that is filled by this jumbo jet. And you might say, well, why are we doing angles and a jumbo jet? And well, when the radius is really huge, think about that. You know, the distance from Rashawn to that jet, it would almost be like a radius, and it would be, we'd have this massive circle that would look something like this, where Rashawn is the center of that circle. And see, with a really massive circle, what happens is a small section of the circle, if you look at just this one small section right here, a small section of the circle actually looks pretty linear. It looks like a straight line. And so when a circle is incredibly huge, the measure of an arc length and the measure of like maybe the straight distance between those two spots really get to be really close. So you can use one to approximate the other. Okay, so in this circumstance, what we're going to do is we're going to say Rashawn is laying on a field. He's looking up. He sees the jumbo jet. The jumbo jet subtends an angle of 0.45 degrees. And because Rashawn is a Boeing engineering buff, he loves that kind of stuff. He knows that a 747 jumbo jet is 230 feet long. And so that would be this distance right here. That's 230 feet. Now, he knows what angle the jet fills. The thing he doesn't know is he doesn't know the elevation or the altitude that this plane is flying at. He does not know that distance right there. Well, in this case, that actually would be our radius. Okay? Because we're looking at this massive circle. So in this case, radius would kind of be the same thing as the altitude at which the plane is flying. And so we can use this idea and we can kind of figure things out like this. This is great. And so what we're going to do is we're going to start with our basic, that we know that arc length is equal to radius times theta. Okay? Now in this case, we have our arc length. That's right here. Our arc length is this, which is this. Okay, our theta, we have that as well. Theta is right here. And what's the only problem with it? Well, the only problem with theta is that theta is in degrees. And to do this, to use this really basic formula, theta always has to be in radians. And so what we're going to do, the very first thing is we'll convert theta. So we'll say, well, we know that theta is equal to 0.45 degrees. And we got to multiply that by pi over 180 degrees. And that helps us then convert this all to radians. Now, this is going to be something that I'm going to plug in on the calculator because you can see this is going to be an incredibly small number. So I'm going to say that theta is approximately, I'm going to grab my calculator here, and I say 0.45 times pi, and then I have to divide that by 180 degrees. And I get 0.00785398. And so I've got this long decimal. Now, I'm going to use that in my calculator. I'm not going to round that yet, but for sake so we can see something, it's about 0.00785398 . Okay? It's about that big. And so what I'm going to do is I'm going to take this value and I'm going to plug it in right there. Okay? And I have this value, and I'm going to plug that in right here, and then I get to look for what is my radius. Another way I could look at this is I can say, well, I could divide theta on both sides and say that radius is equal to arc length divided by theta. All I did was take this formula up above it and just divide both sides by theta, and I get this. And so then right here I go, well, I know my arc length is 230 feet. I know that my theta is 0.00785398 . And so now in my calculator, what I'm going to do is I'm going to say, take the 230 and divide it by my previous answer. 230 divided by my previous answer. And that's going to give me then what the radius is. And it says that the radius is 29,284.509 . And what I'm going to say is let's go ahead and just answer this in terms of 3 sig figs. And in terms of 3 sig figs, we would be able to say that the altitude or the radius is 29,300 feet. That this is approximately 29,300 feet. And that would be how high the plane is flying, what the altitude of the plane is. Now realize, using that this basic formula that we have here, this arc length is equal to radius times theta, as long as we have 2 of the variables, we can solve for the third. If I had, let's say I had the radius, this altitude, and I had the angle, well, then I could figure out how long the plane is. If I had the length of the plane and I knew the altitude, I could figure out the angle. And so you can work this any which way. All right, so what I'm going to have you guys do today, and this is going to be really simple, is I'm just going to have you try 2 more problems just like we did yesterday, the ones that we walked through yesterday, and then you're going to try one like this, but I've changed it just a little bit, okay? And those problems are right here. What I'm going to do is I'm going to take a screenshot of this, and I'm going to post these, okay? So right here are the problems. If you're writing these down or if you're watching this video, you can pause this at this point, but I'm going to screenshot this and post this as well, and I will post an answer key. To get any credit, you'll have to show me the work. You guys have a great day. I know it's supposed to be a rainy one, but have a good, great, grand, wonderful day. Miss you guys.